Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay, so now we move to chapter 3, which is application of differentiation. Okay, so we have 5 subtopic here. Okay, the first one is approximate value and error. Second one is rate of change, and then gradient of curve at a point, maximum and minimum, and also curve sketching. Okay, so this time we will look at the first subtopic, which is the approximate value and error. Okay, so we have here, this one is the first application, alright, for the differentiation. Okay, so we want to approximate the value. Alright, okay, so let's say if we have y equal to fx, okay, so it's a differentiable function. The first derivative dy dx, ataupun we call it as a f prime, is given by the f prime. Okay, so this is the formula that we know. Okay, fx plus delta x minus fx over delta x. Okay, so we have the delta x tends to 0, meaning that it will be it tends to 0, a small number. Observe that fx plus delta x minus fx over delta x does not equal to the f prime. But however, if the delta x is a very small number, okay, the value of this formula can be assumed as approximation of the f prime x. Okay, so when we have the delta x is a very small number, we can equate that one as an approximation of the f prime. Okay, therefore we can write this formula. Okay, so if we have the very small number of delta x, which is approximation value, okay, so we can have this formula. Okay, where the f prime is approximate to fx plus delta x minus fx over delta x. Okay, so if we rearrange, if we bring the delta x to the right hand side, we will obtain this value. Okay, where we can simplify also to this one. Okay, we can make it as a delta fx, where the delta fx is this one lah. Okay, the fx plus delta x minus fx. Okay, so basically we have this formula. Okay, so in order to remember, I think you just remember this formula lah. Okay, so this formula I think is not given in the test, so you need to remember. Okay, alright, so now let's look at the example. Oh, okay, not yet. Okay, Formula 1 and Formula 2 can be used to find the approximate value of fx delta x. Okay, so this is the approximate value lah. Okay, by using the exact value of f, exact value of f prime, and also the exact value of the delta x. Okay, a small increment of fx is obtained from a small increment of x. Okay, so we can use the formula to obtain. Okay, let's say just now we have the f x plus delta x minus fx over delta x, isn't it? Which is approximate to the f prime x. Okay, so now if you want to find the approximate value of this one, which is yang ni lah. Okay, so we just rearrange the formula. Okay, so it's become okay, we bring it there. Okay, therefore it become f x plus delta x. Okay, so which is approximate to delta x f prime x plus fx. Okay, so after we rearrange lah, okay, so we will obtain this one. Okay, so we will use this formula. Alright, okay, alright, so now let's look at the example. Okay, find the approximate value of cube root of 8.03. Okay, so what we know is the exact value, isn't it? The exact value of what? The exact value of cube root of 8. Betul? Alright, cube root of 8 is equal to 2. Betul? Alright, is equal to 2. But we don't know the value for the cube root of 8.03. Okay, we want to find this one. Okay, therefore we can use the formula of the approximate value just now. Okay, we can use this formula. Alright, okay, so now let's try to do this. Okay. Okay, remember our formula just now, we have f x plus delta x minus fx over delta x f prime x. Okay, so if we rearrange, we want to find the fx plus delta x only, which is the approximation value. Okay, so we can make it as a delta x f prime x minus plus lah. Okay, fx. Okay, so we use this formula lah to solve. Okay, so just now we have the first question, which is 8.03 cube root of 3. Okay, alright. So we know that in this case, basically we know the cube root of 3, 8 cube root of 8 only, which is just now I said 2, right? Okay, but this one we don't know. Okay, so now we want to find the fx plus delta x. What is that? Which is, we can assume that 8 plus 0.03. Okay, so for this case, we can assume that our x is 8 and our delta x is 0.03. Okay, so since delta x is a very small number, so we can use the formula here. Okay, so now what we need to have, okay, so we already have the delta x, so now we need to have the f prime x and also the fx. Okay, so what is fx? Okay, so if you look at the question here, okay, here will be we will have basically in general it is x cube root of x lah, isn't it? Okay, so we have basically the x power of 1 over 3. Okay, so now we want to find the f prime. Okay, since we already have f, okay, so now you find the f prime. Okay, so since fx is x power of 1 over 3, okay, which is basically cube root lah, right? Cube root of x, so which is x power of 1 over 3. So we can find the f prime x, which is 1 over 3 x power of minus 2 over 3 lah, right? Okay, so now we know that our x just now is equal to 2. Okay, therefore we can have the f2 equal to 2, isn't it? 8, sorry, 8. Okay, our f is 8. So we just substituting into that one. So cube root of 8 is equal to 2. So f prime 8 is equal to 1 over 3. 8 minus 2 over 3. So you just use your calculator, which is 1 over 12. Okay, therefore now we have x plus delta x, which is our formula. Okay, which is equal to, just now, not equal, this is approximate to delta x f prime x plus fx, isn't it? Okay, so since we want to have 8 plus 0.03, okay, so our approximate value of this one will be this, okay, which is f prime is 1 over 12, okay, so plus our fx is 2. Okay, so we know that this one is the 8.03 cube root lah, okay, which is equal to, okay, so I write this one here, which is this one is the 8.03 cube root, okay, which is f8 plus 0.3. Okay, so this one, the approximate value become, you just use your calculator and to get a 2.0025. Okay, alright. Okay, so that is the approximation value of this. Okay, so if you want to check, okay, maybe you can use your calculator and write this one, and then basically you will get this. Okay, but basically from here, okay, we can use the differentiation, alright, to solve this without using the calculator. Alright, okay, but for check, yes.